Let's start with friction. The definition of friction. Friction is a force that opposes the relative motion of two surfaces in contact. So what does it mean? Force that opposes. So basically, force acts, or the friction, in this case frictional force, it acts in the opposite direction of the motion. If you push a box to the right, the force of friction will be to the left. Okay, so that's an important statement. So if I happen to push an object to the right, or pull an object to the right in my case, the friction will act in the opposite direction. This is a force applied. So the word relative motion, well, where is it? The word relative motion. This is the key, relative motion. Friction only exists when there is an attempt to move one surface related to the other. Only if you try to move something, then the friction starts acting. If not, friction will be zero. If two objects are moving together at the same speed, for example, then there's no relative motion. And so there's no friction. Okay, so example, say you have a good that is very sensitive, right? And this is a platform and this is the good. And what you do is, say you have a way of holding it in place. So somewhere from here also, holding it in place. So if you're able to hold it in place, and yeah, it's still in contact with the surface and it's been transported. Okay, so it's been transported in a box and stuff, in a container. So what happens? The chances that anything happens to the entire structure is minimum. Why? Because if the structure is moving at 10 kilometers per hour, because it's attached to the structure in so many ways possible, this too will move at, so this is one, the conversation went on to this. This too will move at 10 kilometers per hour without any jerk. Okay, so without any lag per se or inertia. Actually, inertia is there, but inertia of motion actually. Not without any, but the minimum. It is reduced. Again, please understand what I mean over here. My language is not. And so, third point is, let me write it over here. And so, friction will be minimum. As relative motion is zero, almost zero. Between what? Between the object and the base of the container. Okay, it's a very important statement. That's why I'm taking a lot of time. Only if you see a relative motion, you see friction being applied. So if two objects are moving together at the same speed, what happens? Like over here, then the friction will be minimum. So friction only occurs, okay, between two surfaces, right? This statement. So friction only occurs when two surfaces are in touch. If something is floating in air, then obviously there's no physical, there is a friction actually over there also, but yeah, we need to have two surfaces in contact. So the amount of friction depends on quite a few factors. Of course, one of that is the material itself. So all of those we'll be talking about it. A small statement. So friction arises because of the microscopic irregularities like here. So this is not an actual photo. This is just an imaginary imaginated photo. Or how do I put it across? It's something that random stuff which we made. So you can see the irregularities. If you zoom into any given surface, there will be irregularities. So when two surfaces are in touch, this irregularities, there's a chances that they lock each other, and this leads to friction. Okay, so they'll be just locked. So nothing will happen over there. Friction will just not arise because of them being locked. When you try to break that lock, that's when the friction comes into picture. Now we look into types of friction. So we have static. Static means what? Yes, when things are not moving, but still you're applying. Okay, so you're applying, and that would be your static friction. Sliding is okay. Once you start moving, then your sliding friction comes into picture. Rolling is, instead of sliding, if the object rolls, then you have a different friction altogether. That's why we have wheels. If not, that is not practical, but if not, our wheel would have been of different design, or there won't be a wheel which is circular, if not for rolling friction being much smaller than sliding. Then fluid friction. So even fluid offers friction. So you get to see that when you kick a ball or you drop anything into water. Again, there are many forces, and that's one of it. Yeah, okay, I do have the definitions. Static friction represented with Fs. It can be capital F and S, small f and s, depends on the book. Where do we see it? When we try to push an object. So in detail, the frictional force resists force that is applied to the object, and the object remains at rest until the force of static friction is overcome. Let me show. So this simulation I'll be using in the first half of the discussion, in this section, that is. So we have an object on the surface. So frictional force you can see, applied force you can see. Frictional force is 0 because applied force is 0. Herein I can apply the force, I can change the mass, I can change the type of object and the surface. Now let's go with this only, and there are other information for you guys to have a look. Now here is a graph. It's not seen, but this is applied force. And when I apply the force, you can see that as in when I apply the force, the friction force also is increasing. So along your x-axis, it's your applied force, and frictional force is your dependent variable. So you need to understand that frictional force comes only into picture when someone is trying to push something, or if the object is already moving or rolling, whatever that is. If not, friction will not come into picture. So if I apply, say, 10 Newton or in this case, it's 30 Newton of force, approximately, the frictional force will also be 30. There will be a certain point after which the frictional force will, okay, it's not technically right actually, but yeah, frictional force will give up and the object starts moving. Okay, so static friction has to do with to that point wherein you have the object not moving. So all this is related to your static friction. Not that, we need to go back to this. When we are looking at kinetic or sliding friction. So kinetic or sliding friction is the friction force resists the motion of an object. So if an object is already moving, again, of course, the irregularities will not disappear. The irregularities will still be there. So this also leads to again a friction, but the amount of friction is different, and so we study it as a different topic altogether. It's known as kinetic or sliding friction. And then we have a rolling friction. So when we have wheel or ball or something rolling down a surface, not sliding, rolling down, then we are looking at rolling friction. And we have fluid friction. That's the resistance encountered by the object moving through a fluid. So fluid, remember, includes liquid and gases. Many people just feel that it's just liquid. No, even gases are fluids, right? So this is the introduction part. You can pause, and yeah, you might have to write most of it